Now we will learn inductance measurement. Inductance. Inductance measurement. Inductance measurement can be done using Maxwell AC bridge or L1 by L4 bridge. So inductance measurement can be done by Maxwell's AC bridge or L1 by L4 bridge. In this bridge, we have 4 arms and AC supply is given. So this one is A, B, C, T. And detector is connected between the point B and D. And this detector may be headphone, maybe CRO. Now, this is L1, this is a known inductance, this is R1, this is R2, and this is variable resistance R3, this one is known inductance, variable inductance this one is, and this one is R4. Now, in this arm, the impedances may be written as Z1. This is Z2, this is Z2, this is Z3, where Z3 is equal to R3 and Z2 is equal to R2, and this one is Z4. Now, this Z1 can be written as R1 plus J X1. So this one is equal to R1 plus J omega L1, and Z4 can be written as R4 plus J X4. This is equal to R4 plus J omega L4. Now R2, R3, this one is known pure resistance. And this one is the detector. Maybe headphone or CRO. L4 is a variable self-inductance. This one is a constant resistance. The bridge can be balanced by varying the L4, and the two resistances are R2 and R3. Now, under balance condition, In the balance condition, Z1, Z3 must be equal to Z2, Z4. The opposite and product of opposite arm impedances must be equal. So this is Z1, this is Z3, and this one is Z4, this one is Z2. Therefore, I can write Z1 as R1 plus J omega L1 into R3, because Z3 is equal to R3. This is equal to R4 plus J omega L4 into R2. See the product R1, we have R1, R3. This one is the real part. And this is R4, R2, R4. This is also real part. So we can equate the real and imaginary parts of the both sides. So equating real and imaginary part of both sides we have R1, R3 is equal to R2, R4. Okay? Or R1 by R4 is equal to R2 by R3. And omega L1 R3 is equal to omega L4 R2. Now, which one is unknown? L1 is the unknown inductance. So, we have to find out L1. So, L1 is equal to L4, you could cancel omega, L4 into R2 by R3. R2 by R3, it can be written as R1 by R4. So, this one is equal to L4 into R1 by R4. So, using this equation, L1 is equal to L4 into R2 by R3, we can find out the value of the unknown inductance. Now, thing is that we can draw the phasor diagram also. How to draw the phasor diagram? Now we are doing it. So this one is the current phasor. So this one is I. Now the drop I1 R1 is equal to the drop I1 R1, and this is I1 current, this is I2 current, this is I4 current, and this is I3 current. Okay? So I1, the drop, I1 R1, and I4 R4 is same phase. So this will be my I1 R1 or I4 R4. Now, the inductive drop. So this will be the perpendicular to I1 R1. So this is I into I1 into J x1 or J omega L1, or I1 into J omega L1. Now, this drop plus this drop, it must be equal to V1. The potential difference is 2 points. This is V1. Now V1 plus V2. This is V2. It must be supply voltage V. So this one is I1R1. So if I connect it, I can get V1. Now V2, that is I2R2. I2R2 in the same phase of I1R1. So this is I2R2. It must be equal to I3R3. So if I draw the parallelogram to R2, if I join it, then finally I can get the supply voltage V. So this V, it must be equal to V1 plus V2. Okay? I think now you can understand. Now you have understood the phasor diagram of Maxwell's AC bridge for finding the inductance, unknown inductance. Again, I am explaining this one. This one is current phasor I. This one is I1R1 drop. This is must be equal to I4R4 drop. And this one is the drop in the induct coil due to L1. So this one will be I1 into J omega L1. And this one is the, if you connect these 2 points, you will get the V1. And this is the I2R2 drop in the same phase with the I. So this is I2R2. That means I2R2 is nothing but V2. V1 plus V2. So the sum of V1 and V2 is equal to supply voltage V. Okay, thank you.